Hi there, my name is Dr. Tishan, and we are going to solve equations by factoring. We are going to factor trinomials, we are going to factor by grouping, we're going to factor quadratics, and I've got some information on the screen here that will highlight some of the techniques we'll use when we get to them. Let's jump right into one of our 4 examples. We'll do a total of 4 examples today, and we are going to use the domain of our real numbers to be the real number system. Okay, so we're going to use the domain of our equations to be the real number system, so not going to work any imaginary problems today. Okay, so let's look at example number 1. Example number 1, we have x squared plus 2x equals 35. We want to find the values of x that make this a true equation. So we want to start by writing all the terms on the left side of the equation and putting a 0 on the right. This is a quadratic equation. So we want to write the quadratic equation in the form of ax squared plus bx plus c. So that's the form we want to write it in first. So we need to subtract the 35 from both sides. Take away the 35 from both sides, you end up with x squared plus 2x minus 35. Anytime you're solving a quadratic equation, you want to move all terms to the left, 0 to the right, just want to separate the variables. Okay, so now we want to solve this by factoring. This is a trinomial, quadratic trinomial, so we want to see, not all quadratic trinomials can be solved using factoring, but this one will work. When you're solving by factoring, we want to look at this number, negative 35, the c value. We've got to find 2 numbers whose product is a negative 35 and whose sum adds up to the b term of positive 2. And that's what it says over here, okay? So the x squared plus your capital bx plus your capital C. You're looking for 2 numbers whose product will give you the c value, whose sum will give you the b value. So what 2 numbers can we use here? Let's see. Well, how about x a positive 7 and x with a negative 5? This is going to work out for us. You have the x squared here. 7x minus 5x gives you your 2x, and then 7 times negative 5 is a negative 35. Look at these 2 numbers here. Their product is a negative 35. Their sum is a positive 2. Right. Once you get this set up, we have 1 term here, so we can go ahead and solve our quadratic. So when you're solving these equations that are higher degree equations, whether they're quadratic and cubic, the idea is that you need to get all terms on one side, and then that one side you're working with, you have to write it as 1 term. We have 1, 2, 3 terms in this step, but you have to write it as 1 term with grouping symbols. Now that we have 1 term with grouping symbols, we can go ahead and take each of these factors. When is this expression equal to 0? When 0 times something is 0, when 0 times something. So we said each factor equal to 0, so x plus 7 equals 0, x minus 5 equals 0. We're going to solve each of these little equations, okay? Take away 7 from this side, you end up with x equals negative 7. All right, add 5 over here, you have x equals positive 5. So the solutions to example number 1 would be negative 7 and positive 5. You can always check your answer by taking the solution that you've gotten and plug it back into the original equation. Check it with a calculator. You should always check and make sure your answer is correct. Take negative 7 and plug it in. Negative 7 squared is 49, and 49, and then 2 times negative 7 is negative 14. 49 minus 14, and it does give you 35. Plug in 5 squared, you get 25 plus 2 times 5 is 10. 25 plus 10, and you do get 35. So you should check your answers as well. All right, so there's example number 1. Let's take a look at example number 2. Example number 2 is a cubic. We want to solve this cubic equation for x. Now, what do we need to do to solve this? We're going to see if factoring is going to be a solution that we can use, and it will be. These examples utilize solving equations by factoring. So it will work here. It doesn't work all the time, but it will work for these examples, so I can demonstrate how it's used. So we have 1, 2, 3, 4 terms, okay? So the whole point with factoring is get the 4 terms. We want to write the left-hand side as 1 term with a bunch of factors, not 4 terms. So we utilize factor by grouping here, and I have a little step-by-step process that you would want to go through with A's and B's and C's and D's. I'm going to demonstrate it here with this example. So we want to group. It's factor by grouping, so we're going to form groups. Our first group is going to be right here, these first 2 terms. And we're going to group these two terms together, factor by grouping. Look at these two terms here, x to the third minus 4x squared. Let's look at these two terms first. What do these two terms have in common? What can we factor out of these first two terms? Can you see that they have an x squared? We can take out two x's from each of these two terms. Dealing with this piece right here first. So you can take out, so if you have x to the third here, take out two of the three x's, you're going to have one left over, then bring down the minus. Look at this term here, you're going to take out the x squared. When you take the x squared away from this term, what do you have left over? You have the 4 left over. Right? So that's what so the first group, you can take out the x squared from each of the two terms in the first group. All right. What about this next group? What can I factor out from these two terms in my next group? 2x minus 8, what can I factor out? I can factor out a 2. Factor out a 2, so what do I have left over from this group when I factor out the 2? Well, take the 2 out of this term right here, you have the x left over, bring down the minus, and then 8 divided by 2, okay, 8 divided by 2, and you have 4 left over. So this is how you start. This is how you start factor by grouping. Now we went from having 4 terms to having 2 terms. To solve this equation, we have to have one term on the left-hand side. We have one term with a series of factors. We have 2 terms here, so we're getting there, but we still have these 2 terms, underline them in green. And what do we need to do with these 2 terms? We need to factor again. We need to factor. So look at these 2 terms now, underlined in green. Look at this term, look at this term. What do they have in common? Do you see the x minus 4 is common to both terms? So we're going to take the x minus 4 and pull it out. Take the x minus 4, we're going to pull it out. All right, so take the x minus 4, pull it out. Let's see what we have left over. First term, look at the first term. You take the x minus 4 out. When you take the x minus 4 out, what's left over? X squared. Okay, bring down the operation sign. So we're done with this. Go to the next term. All right, look at the next term. We want to factor out the x minus 4. Take out the x minus 4. What's left over? The 2 is left over. Notice how we went from 4 terms down to 1 term. Now we can solve it. This is solving by factoring, factor by grouping in this method. So now we can go ahead and solve. When is this expression equal to 0? When either factor is 0. 0 times a number gives you 0. So you want to take both these factors. You want to set both these factors. So you're going to take the factor on the left, set this factor to 0. We're going to set this equal to 0. And solve each one individually. X minus 4 equals 0. Add 4 to both sides. So x is 4. Okay, that one's done. X squared plus 2 equals 0. Let's subtract 2 from both sides. When you subtract 2 from both sides, we're here. Now, what number can you plug in for x and square it and get a negative? Okay, well, that's imaginary, isn't it? That's imaginary. We're only dealing with the real numbers for our domain. So we'll just call this no real solution. So we're just going to write no real solution because that's how we handle it in our class. So, and so here's how you would solve. So the example number 2, your real answer is x equals 4. It's the only real answer. The rest would be imaginary solutions. All right, so we're going to take a look at, we have 2 more examples to do with factoring, solving equations that utilize factoring. So the first example was a quadratic trinomial. So factor by, this is an example here. Second example was a factor by grouping example. So you need to get your 3 terms to 1 term. We need to get our 4 terms to 1 term factored. That's how you solve these. Okay, let's take a look at example 3 is next. Example 3, we've got 4 total examples that we're going to take a look at. Let's look at example number 3 and see how we do it. Example number 3. Example number 3, solving equations by factoring. This will be example number 3, and here is what we have. We are going to take 3, no we're not, we're going to take x times the quantity x squared minus 4, and we're going to add to that 3 times the quantity x squared minus 4. And so here is your third example. Here is your third example. All right. We want to solve for x. That's ultimately what we want to do. We want the solution to this equation. We want to solve for x. We need to, looking at the left-hand side, we need to make the left-hand side into one term. What do we have in this example? We have two terms here, two terms separated by the plus and minus sign without the grouping symbol. So we have two terms here. We need one term. So how do we make our two terms to one term? We factor. I underline the two terms in red. What do these two terms have in common? What do these two terms have in common? They have the x squared minus 4 factor in common. So you can take the x squared minus 4 and you can factor that away from these two terms. That's what they have in common. Now let's see what we have left over when we factor out the x squared minus 4. Look at the first term underlined in red. Take out the x squared minus 4. What do we have left over? We have an x left over. So we took care of the first term. Take out the x squared minus 4, x is left over. Bring down the operation sign, bring down the operation sign. Look at your next term. X squared minus 4 comes out. What do we have left over? The 3 is left over. Now we can solve for x. We took our two terms, wrote it as one term. Now you can solve for x. How do we solve? Well, when you have factors equal to 0, okay, when do you have a product of a 0? This times this equals 0. When is a product equal to 0? When either one of the factors is 0. So take x squared minus 4. We're going to set that to 0. We're going to take x plus 3, set it equal to 0, and solve each of these. All right, add 4 to both sides, so you have x squared equals positive 4. What number times itself is 4? Okay, so 2 times 2 is 4, so x equals 2, but there's another solution, right? So what about negative 2 times negative 2? Negative 2 times negative 2 is also a positive 4, so when you take the square root of both sides, plus and minus 2, you have plus and minus 2 over here, okay? And then subtract 3 from both sides, so negative 3 here are your solutions to this equation. So you have positive 2, negative 2, negative 3, and those are your solutions. You can always check your answers by taking these numbers, plug into the original equation, just make sure that they work out. Use a calculator technology or just mental math. So here's a third example, solving by factoring. By factoring. All right, gotta have that left-hand side, needs to be one term. So we've got one more example. Let's do example number 4. Let me erase this. We're going to take a look at example number 4. One more example here, a different style. I'm trying to get a different style of examples in for these. So here's example 4, looks like this. You have 3 times x minus 1 quantity squared times 2x minus 1. No, x plus 2 to the 4th, I'm sorry. So x plus 2 to the 4th power. Okay, that's your first term. Then there's a plus sign, right? And then your next term, you have 4. You have quantity x minus 1 to the 3rd power. You have quantity x plus 2 to the 3rd power. All right, that's a lot. It's a lot of stuff there, okay? We want to solve for x. We need to solve for x. First thing you need to do is we need to take the left-hand side, write it as one term. How many terms do we have on the left-hand side? It looks really big, the left-hand side, but we have, that's one of your terms, okay, separated by a plus that's not grouped together. There's your second term. We have 2 terms right now on the left-hand side. There are 2 terms, okay? We need to write it as one term, so we have to factor. We have to look at these 2 terms. We have to see what's common to these 2 terms. We have to pull out the common factors, all right? Let's look at these 2 terms, just left to right. Let's start with the constants. That's 3 and that's 4. 3 doesn't go into 4 evenly. 4 doesn't. So there's nothing you can do with the constants, so move to the next term. X minus 1. X minus 1, X minus 1, both spots, okay? We have 2 of them here, you have 3 of them here. How many are common to each of these? You take this smaller number of them out. X minus 1, so you're going to take out 2 of them, all right? So we took care of, so you take the smaller number out, and then the next grouping, x plus 2. X plus 2, you have x plus 2 here, x plus 2. Now we have 4 of them here, 3 of them here. So how many x plus 2 factors are are common to both of these? Well, 3 of them are common to both of these because you're going to take the smaller exponent. You'll take the smaller exponent. All right, so we're here so far. You got to look at these 2 terms and see what do they have in common. They have the x minus 1 and the x plus 2s they have in common, but how many do they have in common, right? The fewer number in the exponents, what they have in common. You got 2 here and 3 here, so you can pull 2 of them out, okay? Or you can't try to use the bigger exponent because you wouldn't be able to pull it out of here, all right? So this is what we're going to pull out of each term. So now we go back over here. We want to look at this first term. We are going to take out 2 of the x minus 1s and 3 of the x plus 2s. Let's see what we've got left over. So what do we have left over when we take this out of this term? Well, you got the 3 up front. Okay, so that 3 constant up front is there. That's not being pulled out. X minus 1 squared. Look, both of those are coming out. Don't worry about the x minus 1s. You're pulling them both out. Okay, what about the x plus 2s? I got 4 of them, I'm pulling out 3 of them. I've got 4, I'm pulling out 3, so I've got 1 left over. I've got 1 left over and I need to account for it, all right? Then you put your plus sign in here, okay? So plus sign because it's the operation sign that separates these 2 terms, isn't it? All right, so we're done with this. We have the 3 left over, you pull both of those out, and then you have 4 x plus 2s here, but you're only taking 3 of them out. So you have an x plus 2 and a 3 is what's left over from the first term. We're done with the first term. Bring the operation sign down. Now we do the same thing with the second term, okay? So what do we do with the second term? Well, there's a 4, okay? The x minus 1s, I've got 3 of them here, but I'm only pulling 2 of them out. I've got 3 here and I'm only pulling out 2, so I'm going to have an x minus 1 left over. What about the x plus 2s? I've got 3 of them here and I'm pulling all 3 of them out, so I don't have any x plus 2s left over. All right, so this is how we would factor. All right, so you have the 2 terms. You want to see what is common to these 2 terms. Whatever's common to these 2 terms comes outside, and then once you pull those outside, see what's left over. Right? So what do we have? We have x minus 1 squared. We have x minus 1 with quantity squared. We have x plus 2, quantity cubed. Right? And then what about in here? Well, let's simplify this. So we have to distribute the 3 in that grouping symbol. So you have 3x plus 6 here. Bring down the plus sign. Distribute the 4 over here. So 4x minus 4 here. And then we can simplify further, so we just carrying this down, so x minus 1 squared, x plus 2 quantity cubed, those are the factors, that's what we factored out. All right, combine like terms here. How many x's do I have? 3 x's, 4 x's, I have 7 x's. What about 6 and a negative 4? That's a positive 2. And here we go. We took our 2 big terms here. This is 1 term. Now that we have 1 term, we can figure out when are you going to get a product of 0 when any of its factors are 0. So we will need to take each of these 3 factors in order to solve and figure out when any of the factors. So this product will be 0 when either x minus 1 quantity squared is 0, when x plus 2 quantity cubed is 0, or when 7x plus 2 is 0. All right, so this is when our factors are equal to 0. Let's start over here. Okay, x minus 1 quantity squared is 0. Okay, take the square root of both sides. The square root of the left just gives you x minus 1, and the square root of 0 is 0. And then add 1 to both sides. So x equals 1 is one of our solutions. There's one of them. Next one, x plus 2 quantity cubed is 0. Take the cube root of each side, so you end up with x plus 2. The cube root of 0 is 0. Subtract 2 from both sides. So you have negative 2 here. And finally, subtract 2, so 7x equals a negative 2. Divide by 7, x equals a negative 2 sevenths. And these are your solutions to this equation up here. When is this expression going to give you a 0? And you can use your calculator to check your answers, but when x equals 1, you'll have a 0. When x equals -2, you'll have 0. When x is -2/7, you'll get 0. So here are your solutions to this polynomial equation. So solving equations by factoring. The idea is that when you're solving equations, or especially these polynomial equations, you need to write your one side, the left side, as one term. It needs to be one term of a series of factors. If it's not one term, then you're going to have to use your strategy of factoring to write it as one term. Okay, so you just need to write the left-hand side as one term. Sometimes it's a trinomial, quadratic, so you have to write it as one term before you can solve. Sometimes you'll utilize factor by grouping, right? And sometimes when you get into upper level math classes and you're using different strategies and techniques, you've got something like this going on. All right? Very good. So thank you for watching, and hope this helps. Okay, thank you. Bye-bye.